Welcome to Building Envelope Diagnostic Testing, a WISE educational program brought to you by Console. This course is a WISE educational program brought to you by the California Energy Commission's EPIC program. At the end of this course, you will be able to identify required equipment for insulation density diagnostic verification, understand how to perform insulation density testing for blown-in insulation, understand how to measure the thickness of spray polyurethane foam, identify required equipment for envelope diagnostic testing, prepare the house for air leakage testing, and understand how to perform air leakage diagnostic testing. Verification of blown-in insulation density and spray polyurethane foam insulation thickness for QII. The purpose of this verification is to ensure the correct amount of insulation has been installed in accordance with manufacturer specifications and QII requirements. It also allows us to confirm that the installed insulation is in compliance with the R values listed on the CF1R. The coring tool is used to collect a sample of insulation that represents 1 square foot of insulation. It needs to be deeper than the thickest insulation sample. If your bucket does not have an interior diameter of 13.54 inches, you will need to perform a conversion to account for this difference. A small scale will be used to weigh the sample taken with the coring tool. It will need to have an accuracy of plus or minus 2 grams or 0.004 pounds. Blown-in insulation must be installed to the thickness required by the manufacturer for the target R value. At the time of installation, measure to ensure it meets the initial installed thickness. This is oftentimes greater than the installed thickness to account for settling. The installing contractor will need to certify that the minimum weight per square foot has been met by following the guidelines found in the Insulation Contractors Association of America Technical Bulletin 17 or 33. The sample should be taken from an area that appears to have the least amount of insulation installed, and the results will be documented on the insulation certificate. The following steps are taken from the IACC Technical Bulletin. You will need your coring tool, scale, and an empty container large enough to hold the insulation sample. Press the coring tool into the insulation to the full depth, being aware of possible obstructions hidden by the insulation. Place the empty container on the scale and zero it out. This will remove the weight of the container from the total weight, leaving you with just the weight of the insulation sample. Now move the insulation from inside the coring tool into the container. Record the weight displayed on the scale. If your coring tool has an area that is not 1 square foot, you will need to divide the weight of the sample by the area of the coring tool in square feet. Last, you will compare your result to the target provided by the manufacturer. Each material will have a unique chart specific to that material. Your result will need to be equal to or greater than the target weight. Probes are used to measure the installed thickness of spray foam insulation. They need to be accurate to within plus or minus 1/8 inch and only cause minimal damage to the insulation. Insert the probe into the insulation at 6 random locations for each surface type to measure the installed thickness. This is done to ensure that minimum thickness levels were achieved and R value requirements met. Information about the installation is required to be documented on the Certificate of Installation. The CF2R-ENV-03 is required regardless of whether QII is taken or not. If QII is taken, you will also need to complete the CF2R-ENV-21, 22, 23, and 24 forms. If QII or any other HERS measures are required on the project, the previously described forms are required to be registered in an approved HERS registry. Air leakage testing. The purpose of the building air leakage test, or infiltration test, is to measure the infiltration or exfiltration rate of the envelope. Air leakage is measured in cubic feet per minute, and the test is performed with a pressure difference between the indoors and outdoors of 50 pascals. The pressure gauges need to measure the pressure difference with a resolution of 0.1 pascals and have an accuracy of plus or minus 1% of the reading or 0.5 pascals, whichever is greater. There are several types and manufacturers to choose from. The most common are listed here from the Energy Conservatory and Retrotech. The fans used to pressurize or depressurize the house need to have an accuracy of plus or minus 5%. As with the pressure gauges, you can choose from different manufacturers. Again, the Energy Conservatory and Retrotech are the most common. The pressure gauges and fans need to be tested annually for calibration. You can use the field testing method as approved by the manufacturer or send the equipment to a company that specializes in equipment calibration. Log all tests and results and keep that information for a minimum of 3 years. The home will need to be prepared for testing. You will need to verify the status of the following items. Doors and windows that separate conditioned space from unconditioned space shall be closed and latched. If the blower door is installed between the house and the garage shall be opened to the outside by opening at least one exterior garage door. If a crawl space is outside the conditioned space boundary, interior access doors and hatches shall be closed. If a crawl space is inside the conditioned space boundary, interior access doors and hatches between the house and the crawl space shall be opened, and exterior crawl space access doors, vents, and hatches shall be closed. If an attic is outside the conditioned space boundary, interior access doors and hatches shall be closed, and exterior access doors, dampers, or vents shall be left in their as-found position, and their position during testing shall be recorded on the test report. If an attic is inside the conditioned space boundary, interior access doors and hatches between the house and the conditioned attic shall be opened, and attic access doors and windows shall be closed. Interior doors shall be open within the conditioned space boundary. Chimney dampers and combustion air inlets on solid fuel appliances should be closed, as that is the natural condition. With depressurization of the house, it is possible to draw ashes or soot into the home through chimneys, even if the damper is closed. Take extra precaution in these situations by temporarily sealing these openings, and note this in the test report. Combustion appliance flue gas vents shall be left in their normal appliance off condition. Any fan or appliance capable of inducing airflow across the building enclosure shall be turned off. This includes, but is not limited to, clothes dryers, attic fans, kitchen and bathroom exhaust fans, outdoor air ventilation fans, air handlers, and crawl space and attic ventilation fans. Continuously operating ventilation systems shall be turned off and the air opening sealed, preferably at the exterior terminations. Motorized dampers that connect the conditioned space to the exterior shall be placed in the closed position and shall not be further sealed. Non-motorized dampers that connect the conditioned space to the exterior shall be left as found. If the damper will be forced open or closed by the induced test pressure, that fact shall be reported in the test report. Clothes dryer exhaust openings should not be sealed off even if there is no dryer attached, but this fact should be noted in the test report. Undampened, fixed dampers, or intentional openings between conditioned and unconditioned space shall be left open or in the fixed position, and any temporary blocking shall be removed. The only exception is for continuously operating mechanical ventilation systems, which shall have the fans turned off and the vent sealed, preferably at the exterior of the enclosure. Whole building fan louvers or shutters shall be closed. If there is a seasonal cover, it shall be installed. Evaporative coolers shall have the opening to the exterior placed in its off condition. If there is a seasonal cover, it shall be installed. Operable window trickle vents and through the wall vents shall be closed and/or sealed. Supply registers and return grills shall be left open and uncovered. Plumbing drains with P-traps shall be sealed or filled with water if empty. Combustion appliances shall remain off during the test. If during the test, the induced pressures affect operable dampers, seasonal covers, etc., re-establish the setup and consider reversing the direction of the fan flow. Use caution when deciding how and whether to test homes with potential airborne contaminants, such as fireplace ash, mold, or asbestos, and refer to local, state, and national protocols and standards for methods to deal with these and other contaminants. Depressurization should be the default method used, only using pressurization to mitigate potential hazards. Install the blower door system in an exterior doorway or window that has unrestricted access to the building and no obstructions to airflow within 5 feet of the fan inlet and 2 feet of the fan outlet. Avoid installing the system in a doorway or window exposed to the wind. It is permissible to use a doorway or window between the conditioned space and unconditioned space as long as the unconditioned space has an unrestricted air pathway to the outdoors. For example, an attached garage or porch can be used as the unconditioned space. In this case, be sure to open all exterior windows and doors of the unconditioned space to the outdoors. Start by assembling the frame per the manufacturer's instructions. Insert the assembled frame into the opening and expand it to match the size of the opening. Drape the tarp over the frame and secure with Velcro. Be sure the fan opening is at the bottom of the frame and that you have access to the locking levers. Place the covered frame into the opening and secure by adjusting the locking levers. Put the reference hose through the provided hole in the tarp and place the end a minimum of 5 feet to the side of the fan outlet. If it is windy, refer to the manufacturer's instructions for ways to protect it from the effects of the wind. Insert the fan into the opening, being aware of the direction of flow. The flow will need to go to the outside of the house so we can achieve depressurization of the interior. Connect the gauge per the manufacturer's instructions. The blower door is now ready to start the testing procedure. There are 3 acceptable air leakage test procedures: the single point, repeated single point, and multi-point test. The single point test is the most commonly used method. This measures air leakage one time and at a single pressure difference. Prior to starting the test, you will need to document the indoor and outdoor ambient temperatures in 5-degree increments. If the building is at an elevation greater than 5,000 feet above sea level, record the elevation. A single point test may only be performed if the maximum induced building pressure is at least -15 pascals and greater than 4 times the baseline pressure. If the maximum induced building pressure is more than -15 pascals, this means it is closer to 0, recheck that the house is set up correctly and determine if any basic repairs are needed prior to further testing. Choose and record a time averaging period of at least 10 seconds to be used for measuring pressures. With the blower door fan sealed and off, measure and record 5 independent average baseline building pressure readings with respect to the outside to a resolution of 0.1 pascals. This allows the meter to account for ambient conditions and provides a more accurate result. Unseal the blower door fan, turn it on, and adjust the fan to create an induced building pressure of approximately negative 50 pascals. If a negative 50 pascal induced building pressure cannot be achieved because the blower door fan does not have sufficient flow capacity, then achieve the highest induced building pressure possible with the equipment available. If you are using a digital meter, utilize the at 50 function to account for lower than target pressures. Then record the following information: induced building pressure, nominal CFM 50, fan configuration, and fan and manometer model and serial numbers, which can be found on the equipment tags. This is where those data points are located on the DG700, and here is where the data points are located on the DM2. Once you have completed the test and collected the required data, you will need to enter it into a HERS provider's registry. Information about the installation is required to be documented on the certificate of installation. If building air leakage shows as a compliance requirement on the CF1R, the certificate of installation forms will be required to be registered in an approved HERS registry. The information in this training comes from the 2016 Residential Reference Appendices, sections 3.5 and 3.8. It can be downloaded for free from the California Energy Commission's website. This has been Building Envelope Diagnostic Testing, a WISE educational program brought to you by the California Energy Commission's Electric Program Investment Charge program. For more information, please use the contact information on the screen.